Special extinguishing systems are used where automatic sprinklers may not be the best solution to fire problems. Special extinguishing systems are classified by the type of extinguishing agent they use. They include wet chemical systems, dry chemical systems, gaseous systems, and foam systems. The type of system installed is determined by the hazard to be protected. Special extinguishing systems should be installed, inspected, tested, and maintained according to the manufacturer's instructions and in compliance with national, state, and local standards and codes. Fire department personnel should have a basic familiarity with these systems, but inspections, testing, and maintenance should be performed by trained individuals. Areas such as food preparation areas, combustible metal milling, or highly sensitive electronics are examples where special extinguishing systems may be used. The four types of systems we will discuss are wet chemical, dry chemical, gaseous agents, and foam systems. Wet chemical systems can be messy, and the extinguishing agent may migrate from the fire area to surrounding equipment, possibly even causing damage where there was no fire damage. Engineered systems are designed for a particular installation for a specific hazard. These systems are larger and more costly. More common is the pre-engineered system that you will find in many commercial kitchens. While on company inspections, pay attention to the system components, particularly where the nozzles are pointed. If the nozzles don't line up with the cooking device they are designed to protect, there may have been a change in the occupancy or operation. Doing so may require the occupant to have the system updated. Monthly inspections and/or tests are typically not conducted by fire department personnel. These inspections may be performed by a contractor or an employee that has been trained to perform these types of inspections. Semi-annual inspections are also conducted by personnel trained to do so. Dry chemical systems may be used to protect flammable or combustible liquids and gases, dip tanks, paint spray booths, exhaust duct systems, commercial cooking installations, transformers, marine applications, heavy diesel equipment such as earth mover, excavators, etc. These systems discharge a cloud of extinguishing agent that leaves behind a residue that creates a significant cleanup for the entire area, even that which was not involved in the fire. Furthermore, dry chemical systems are not recommended for areas of sensitive electronics as the residue is quite corrosive. Gaseous systems may be installed to protect radio and television equipment rooms, computer rooms, high-value equipment, flammable liquid storage and dispensing areas, printing presses. These systems agents are considered clean because they leave behind no residue, reducing property damage and cleanup costs. CO2 can be set up to deliver the agent to a specific location or as a total flooding system. The risk with CO2 is that in the total flooding system configuration, the area becomes oxygen deficient, creating a risk for occupants and responders. These systems will be placarded and alarmed to notify occupants and responders that the system has been activated. CO2 systems may be designed to operate automatically upon detection of a fire or manually by occupant activation of a pull station. High-pressure CO2 systems have CO2 stored in DOT cylinders at a pressure of 850 psi. Low-pressure systems are for larger applications and have the CO2 stored in large refrigerated tanks. Maintenance and testing on these systems will also be done by trained technicians. However, while performing company inspections, check the system to ensure the piping, containers, and nozzles are not damaged, corroded, obstructed, or rusted. Foam systems may be installed to protect areas with flammable liquids processing or storage, aircraft hangars, rolled paper, or fabric storage facilities. Foam system installation guidelines are provided by several NFPA standards. A fixed foam system is a complete system with a foam, piped from a proportioner station to the location to be protected. It can be a localized application just for the hazard, or total flooding using low, medium, or high expansion foam. A semi-fixed Type A system has the piping in place but not connected to a permanent source of foam. This may be a tank farm where one foam truck can connect to the appropriate system to deliver foam where it is needed. A semi-fixed Type B system has piping with a foam supply connected to it and with hydrants that allow the connection of hoses to the system. It is similar to a fixed foam system, except that a fixed foam system applies the foam to the hazard, while semi-fixed Type B system makes foam available. A high-expansion foam system is designed for local application or flooding. The difference between a fixed system and a high-expansion foam is the amount of the foam expands by the use of a foam generator. Foam water systems is similar to a deluge sprinkler system, except that it delivers foam also. Foam extinguishes fire simply by taking away one aspect of the fire tetrahedron. To generate foam, 4 components are needed, which has come to be known as the foam tetrahedron: foam concentrate, water, air, and mechanical agitation. Once all 4 components are present, generating foam is a 2-stage process. The first is mixing foam concentrate with water in the correct ratio, which is called proportioning. The second stage is to generate bubbles by mixing air with the solution during mechanical agitation. This is called aeration. Foam proportioners work on one of 2 principles. Foam is picked up by when water rushes through the adductor, creating a Venturi effect, or foam concentrate is injected into the system stream under pressure. Line eductors use water moving through them to create a Venturi effect, drafting the foam from the container into the stream of water. Balanced pressure proportioners allow foam concentrate to be put into different lines at different rates, or not at all, allowing cooling lines and foam lines to run simultaneously. Around the pump, proportioners use a proportioner below the foam tank to put foam into the water on the supply side of a fire pump. The foam is put in at a particular proportioning rate for a specific flow rate, and the pump is solely dedicated to foam operation. The pressure proportioning tank uses multiple tanks of foam concentrate. Water is pumped into the foam concentrate tanks between the tank and a bladder. The foam in this bladder is displaced by the water and is added to the discharge water. A coupled water motor pump proportioner is simply 2 rotary gear pumps, one larger than the other. Water flowing through the larger pump causes the smaller pump to turn, drafting foam from the tank. The pumps are sized proportionally to draft and inject the foam at a fixed 6% ratio. Premixed foam is found in stored pressure portable extinguishers. They can be hand-carried, wheeled, skid units, and vehicle-mounted.